Yeah, it really is.
Okay, the microphone's on. That's why
No, that is true. You're literally driving around. You just drive around the street. No, don't do that. It's not even hit like that. Don't touch him.
In the bag.
Don't touch him. Oops.
My
bad. Yeah, why can't you?
I asked Louis, why can't Reggie drive together? And yesterday I drove the night and like, wait, Tara, why can't Reagan just drive to her house?
Reagan's already home.
And I don't think Reagan can stand. Actually, she might come to this.
No, she was in my class.
So then the lawyer should, if she's going to Reagan's house, then Reagan.
Well,
But
Megan,
Lucy's
can't
gonna make
Megan
me
drive?
drive. Oh, that's good. Lucy should drive me. Wait, why?
Why can't
She
you
said
drive?
no.
Huh?
I still want
Tomorrow.
to.
It's our color.
What's our color?
And we're red.
What?
That's so boring.
Yeah,
I mean,
and,
doesn't she
It
share a
looks like
car?
some purple.
yeah.
Some green.
She doesn't have to pay for it.
Yes, last year we had green and it was disgusting.
I know.
No, that's just really cute.
Heyo.
It lasts a long
Not a win
time,
on Christmas
and,
Eve.
no,
It's all red. It's so good.
I know, everything.
And I'm wearing
It's like
Christmas
50
Eve.
miles to the gallon, and.
I'm
Ow.
wearing Christmas Eve.
That was
Well,
hard.
if you get a full, if you get a.
No, that was hard. Yeah.
Or,
so-
I mean,
I'm
if
wearing
you get a full
I'm wearing
tank, it's
Christmas
only
Eve
15
prom.
dollars.
17.
Mine's $50. Dude,
No, mine-
yeah.
Mine's-
My sister filled 3/4 of a tank. It was 47 cents. Say I went dressing as mom. And I have a little fucking seat in my car.
Isn't that pretty legit?
You put way too much effort. And I have
All I did was put a pencil. I didn't put my hair, and I put my hair in.
I don't want this.
Yeah, no, you guys need to get like a.
Yeah, I'm gonna trip my car for a
No, you should, then you should.
Would you rather have
I
the-
bought my own car.
I didn't believe it until you told me.
I bought my own car, and now I'm gonna drive for gas.
So if I put on a Christmas suit, you wouldn't get it.
No, I'd be like, what the heck are you doing?
And you seem like minimum realistic. My friend Lauren.
Good morning, Chloe.
Good morning.
Do we light stuff on fire today?
No, her voice went strong.
Like, who makes that shit up? I had a big.
No, you're not.
I was literally, I was just going.
Oh.
All right, we're going to wait for the pledge and then we'll get started. I'm tired. How you doing, Emma? How you doing, Karen?
Oh, he didn't have any.
What's new, Keith?
I'll trade you. I'll walk you through the platform. It's cool. I'll walk it up. I'll trade you.
We're just waiting for the pledge. There we go.
Place your right hand over your heart and begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all.
Okie dokie. So today we're going to do the Charles Law Lab. Okay. The Fruit Loop lab, I shouldn't say lab, the Fruit Loop worksheet is due Friday. Okay. Because I really do want us to work on it in class so I can fix mistakes as you go. Some things, if you learn it wrong the first time, it's hard to undo it. Like I was taught the word behavior wrong, so I still spell it wrong to this day. Yeah, I spell it the British way with a U.
Well, how do you spell color?
I spell color correctly, but you know, if I spell behavior the right way, it just looks wrong to me. Like my brain looks at that and says it's spelled wrong. So I always spell behavior with a U, even though it's wrong. By the way, how do you spell gray?
No, actually, the EY is like not real. It's like made up.
No, actually, if you look Webster's English Dictionary, you can spell it either way. AY or EY. And how do you spell blonde?
With the E at the end, yeah.
You can actually spell it either way, according to the dictionary. All right, anyhow, we're not here for English, are we, Drew? So the virtual only students, you will be watching me do the lab, okay? I videotaped it, and I'm just gonna show you where it is, although I'm sure you can find it. If you go into Canvas, oh, that's the wrong Canvas. I start my Spanish class tonight. I'm going to go back to school to refresh my memory on Spanish. Okay, this is the correct Canvas. If you go into gas laws, at the very bottom of gas laws, you will see Charles Law Lab. That's where you would go to get the worksheet. And the video link is right next to it, where it says Charles Law Lab data. So, not that. So the video Charles Law Lab data, that video is about 15 minutes long, okay? Now, it'll take the in-person students probably about 30 minutes to do it. The reason why, Maria, is because I know what I was doing, so I could do the lab very quickly. You guys are doing it for the first time, so you might make a few mistakes. So probably everybody will be done doing the lab probably at 10:40, okay? So for those of you who are virtual at 10:40, make sure you are on the Zoom so that we can go through the data calculations together. Again, the rest of you virtual people should be watching the Charles Law Lab data video and using that data, okay? Right, Amanda, you got it? Do you know what you're doing? Does everybody at home know what they're supposed to be doing?
Yep.
Karen, are you good? Okay. Keith, you good? Yeah, you just said you were. Lola, you know what you're doing here? You're watching the Charles Lab. Okay, you'll probably want to upload the worksheet into Notability to write your data down, okay? So I would upload the worksheet first so you can write all the data in the correct spot. Any final questions? This is called wait time. You got to wait at least 30 seconds for people's brains to catch up, to process. It takes a little while to think about questions. It'd be helpful if I didn't talk during that 30-second wait time period, but
Are you following this or are you gonna like walk through it a little bit?
we're gonna read through the directions. Okay, I'm gonna mute myself so that I don't distract you guys at home, okay? But I will have the chat up in case you have questions, all right?
Okay, bye.
And what I'm gonna try to do is I'm gonna get the water level inside the flask and outside the flask equal. The reason why I want this water
Your stuff
level,
is unmuted.
this water level Did you find it, Karen?
Yes, I did. Thank you.
Okay. Thanks, Chloe, for your help. Just an FYI for you guys at home, I think we'll be ready in about 10 minutes. Okay, so make sure you're ready to go in 5 minutes, but my guess it'll be another 10. All right, can you guys at home hear me? Can you give me a thumbs up? I got one from Chloe, Drew, Celia. Ayan, are you okay? Lola, are you all right? So hopefully you were able to write down your data. Get your calculator ready. We're going to start. If you don't have a calculator, you might want to grab a calculator.
Oh, I have what? Oh, you just -5 -4. No. Five, like, no, I got that too. I didn't understand the word for this one, but now I find it.
All right. You ready, Morgan?
Yeah.
Okay. So again, you are using your own data. You are not using my data. You are using your own data. Okay. So when I'm grading this, I'm looking for you to be using your own data. All right. So we're going to go slow. And so just a reminder for the Zoomies, you know, if I go too fast, you got to chirp up too. Because I can see visually the students in class if they need more time, but I can't visually see you guys at home if you need more time. So you have to let me know if you need more time. All right, so the first thing we're going to do is we're going to graph, okay? So we know our T1. We know our T1, we know our T2, we know our V1, and V2 is just step 5 minus step 4. So for me, that would be 232.5, okay? So we're only gonna have 2 points on our graph, and we're gonna use either Desmos or graphical analysis. I'm gonna use graphical analysis, but you can use whichever one you want. I'm just gonna give you a rough sketch of what the graph should look like. You should have temperature in Celsius on the x-axis, and I want it to run from 100 to -400. And on the y-axis, you should have volume in milliliters, and that should run from to about 400. So there'll be a reason why I want that thing to run to -400 degrees Celsius. Now, ULARs are infinitely smarter than a computer. So do not just trust the computer to do things correctly. There's going to be 2 points. So just because you label your axis temperature doesn't mean it's going to graph temperature. For example, is that my correct T1 V1? So this is where I'm saying, like, take your time and think about what the computer just did. It's saying that my initial temperature is about what? About 270. Did we have a temperature of 270? No. What did we have that was 270? Volume. So just because the computer puts a data point out there, it doesn't mean it's right. So that means we have to just re-enter the numbers in a different way. Would this be correct for T1 V1? Yes, right? Our initial temperature was around 100 and our initial volume was, so this would be correct. So I'm just, you know, I'm teaching you chemistry, but I also want to teach you how to do science and how to think. So when you put your data in there, You have to think, Ian, about whether or not that is the right representation. Don't just assume the computer did it right. And then we'll have T2, V2, which will be somewhere around here. So you're only going to have 2 points. All right, now we're actually going to use the graphical analysis to do this. I just wanted to give you a rough idea of what it looks like and how you should label your graph, okay? Linear, okay? Now this is, we collected this gas over water. So do you remember what we call a gas that's collected over water? We call it wet gas. So vapor just means that your liquid evaporated. Okay. So when you're pumping gas and you can smell the gas, that's gas vapor. Okay. If you can smell vinegar, that's vinegar vapor. Okay. All right. So this is going to be for wet gas. So that's the title of our graph, wet gas, because we collected it over water. So I am going to use graphical analysis. You're more than happy to use any other program, but I am going to do it right now. You guys at home, use your graphical analysis or Desmos. And choose manual entry. On the x-axis, it should be yeah, or you can attach it. There are a number of ways you can do it. So we're just going to graph our data, okay, in whichever program you find more easy for you. Graphical analysis or Desmos, it's up to you. No, got to use a computer. This is the technology age. You can either screenshot it or you can export it into Notability. It doesn't really matter. Bars.
I did. They fit my face pretty well. What are we thinking?
Wet gas.
Are you doing volume on?
So T1, V1, and T2 and V2. So T1 and V1 and T2. Yep. So and you can see how I did it on my little table up there.
Yeah, it doesn't let me edit the data set.
It will. You just gotta click on it right. You gotta touch it. No, I'm gonna come by and just see that.
Okay, wait, now just like added something. Yeah, I did that too.
Yeah.
You just started. How do I get it? I did.
Wow, that's great.
But he wants, it won't let me.
So you change that.
Just let me delete it.
He wants, yeah, the new data, yeah. Why?
Oh,
No, it's, I would want to show you that. You don't want to. Mr. Strauss, how do you delete this now? The action you did. Yeah, I can do that.
I'm already starting.
Well, it like won't let me edit them. No, it doesn't let you. No, it doesn't let you see it.
Yeah, it's my fault.
And it won't let me edit things that you, to edit the name, you have to go out of it.
98.7.
No, not like the name of the like actual thing. Like,
Nope,
see,
nope,
on
nope,
the
nope.
here, see how the buttons.
Yeah.
Okay. And then, who's touching me? Larry, you have. I can't say that.
What are you?
So I already like screenshotted like one of it, but it doesn't say what gas is outlined.
So
Can I just
you
like
wanna
color
send it
it?
out?
No, I know how to do this.
Get it to me.
You go like this.
Okay, so.
Here, is this fine? It says 300 on this.
Yeah, that's.
Then you
Okay.
apply to it.
Does he want us to- I can say no.
Oh, there's not enough points.
If you want it, I want you to check out to.
Oh, they just give like a portion.
I want you to see that graph is now cost effective.
Renee, bring it here.
It's just like I lost my point.
Negative
Where'd the points go?
I've been advanced.
In other words, your volume will continue to get smaller.
I give up.
That's the coolest you can get. You can't have negative volumes. Talk about negative. Oh, no. So let's plan on living together.
Well, sure.
Got it.
I don't know.
Oh, wait a minute.
You're really rambling
Mr. Strauss, online is not.
Yeah, you need to, you remember what we did before? Yeah.
Mr. Strauss.
I'm hitting something.
What?
Here, Alex.
No.
I can only fight with.
Okay. It's still there.
I have to leave my hand like this.
Where is it like?
Oh,
I don't know,
so
if
you
you're
rather.
like, you can kind of like pull out of the stuff. On
My biceps are biceps are.
Or you're taking it for the end of the fight.
What do you think?
Wait, what's the actual fight?
Taking the native.
Yeah,
No, but like the actual.
there's like a
Oh,
lot
no
of
one's
random.
gonna die.
People just jump in
Wait, Caden's gonna be fully healed.
Wait, you think Noah's?
He's already full.
Oh,
But he's gotta like, he can't just go right into like.
Are people wearing gloves or this?
Oh, good call.
Yes, they're right.
Oh,
It's a
okay.
boxing.
What other ones are there?
So, jeez, what?
So you're gonna get a
I don't know.
Just corner.
Does
But
one
like-
actually get burned?
But there's memorial dudes that could like Blake, like they want him. It's like legit now.
No, Miller kept calling this. You gotta play for him. You gotta play for him. 'Cause
Oh,
Graham and
Joey
him-
would end Graham.
No, because Graham and him have like beef or something.
No, Graham just
For
started.
what?
dating
Because
the
Graham just randomly posted on his story being like,
I don't
"Who
like
is
this guy.
this dude? I wanna punch him in the face or something." And Joseph was like, "I don't even know who this is."
Well, wasn't he commenting that you guys were like posting?
Yeah.
Like never protocol.
Plus,
Like,
everybody gotta do their own graph, unless you guys plan on living together in college, all of you guys gonna have to graph on your own.
Wait, where's my iPad? Stop.
Who are you?
who are you? And then another. And then Riley puts his profile picture. I don't know.
There's someone's Instagram comment
It was Joseph.
I remember this so
so.
vividly.
It's still up.
So I'm not sure what you did, try,
This is like when
I can
all
just
of my
redo it.
Instagram, like,
Try
got
redoing
fired,
it.
and then oh, but you gotta come, you gotta come. I don't even have an
so then you
Instagram.
gotta type in T1V1. So you type in 96.
No, I kind of want to play.
Three.
That's probably not.
I don't really know what he looks
T1,
like.
which is
I've never.
70.
He's not.
What's his last name? Roderick?
Yeah.
I know Graham, dude. Everyone has just like boyfriend.
Is he like, how old are you? Okay.
He's hilarious.
Oh, why do you say it like that? Like I'm small. Oh,
You're not as tall as those
thanks.
No,
I already tried myself.
Mine, no, try regraphing it. Cause like mine, boom, I'm not sure why it's doing that. So when you're, Morgan, tone it down a little bit. So for you guys at home, make sure that you click on, apply curve fit. Maybe you have an older version. Maybe that's it. Because you're gonna need this equation. Evan, could you do me a favor and put that ruler in the back of the room?
Okay, wait.
So we'll go about 2 more minutes. Does anybody at home need some help with your graph? We'll write the equation in a second, but if you click on that.
I'm working on it.
No, but I was.
No, let me try.
Joseph, if Joseph uses height effectively, he can take out branch.
How do you use height in a fight though? His arms are just really long.
Or like make
Manual
make
entry.
an upper height.
But what if your arms like go?
Giant.
No, so
Punch it backwards?
basically Joey will be punching down at him,
Yeah.
which is nice.
Yeah.
Bram has to go up.
No, that's just.
But then
all I
Graham
meant
is
was
here,
about-
Joey's gonna be staring down.
You don't think I'm weak?
No.
You don't have
That's
to,
right.
you don't have to bench.
You use your legs
That's why I don't get why people in the garage would be in a fight.
versus you.
Yeah.
I don't think either of
We
you would
wouldn't say
end up
Riley
winning in
would
that
There you
situation.
go. I don't know. Did you do another one?
I would beat him.
I don't know.
I think you would win, but
I'm
Oh,
stronger
Mr.
and
Strasser.
taller.
I'm gonna lie either.
I'm
So,
stronger and taller.
it depends if it's like.
This is too
dude, why ain't getting no line?
You have to make it.
How do I make a line? I did, bro. It's not there.
Who should I invite?
Mr. Josh. My line is not present.
Like curve fit.
I need a line. I need a line.
You have to click on that.
No, not.
Billy, did you get a line?
No, it says too few points.
Everybody else gets the line, but you get it.
Yeah, and Billy, I didn't get a line. What is it?
Whenever I do it, it says too few points.
I didn't get a line.
I did, I was joking.
I'm
I'm not.
Your volume on the flash is 250?
Yes.
Ours was like.
You filled it with water and you put the cord in.
And I put the
Yeah.
cork in.
Yeah,
Ours
ours
was
is
252.
Everyone's is higher than
Yeah, it's like
Or like 250 or higher.
It is?
Ours was 289.
Yeah, they should be all,
Ours was 250.
they should be,
Ours is 250.
Ours is 249.
they're gonna vary. They're gonna vary. That's why I'm just surprised. Did you just dump the water out in there and then did you actually read the graduated zone?
No, we did. It was on the
Yeah,
line.
we just put the plug in
Mr.
it.
Strauss, you act like I can't read a graduated sim.
Let's check in.
What about that last test?
That had nothing to do with graduated sim.
Should take graduate school.
Right.
Just for Alan.
I think Alex aced one.
Right?
Finley, you're in the same group.
Yeah. You know, I don't know. I think it's just the lab.
It says too few points, and I'm
How
gonna
come everybody else
lose
is-
my mind.
Except me and Tim.
Except you and Finley, and that's great that you both have to be the same lab group.
Because our data is just cool.
So
That's really
you're
weird.
gonna have to calculate
I
the,
got one.
yeah, but you're gonna have to calculate, can you know how to put that in your, give a graphing calculator?
I think.
Timmy does.
You can also do the slope using the graphing calculator.
See, I feel like that one's really.
Oh, you can get the slope. You just, yeah, that's easy. Billy, we gotta get the slope.
Y equals mx.
All right, guys, so I'm gonna write down my equation. So the equation is off of your graph.
Yeah, that's what I was.
Okay, so Tara, Morgan. So you take your equation, okay? I know my slope. I know the y-intercept. right? Do you know what you're doing, Lily? Yeah, it's just a thing on there. So I know my slope is m, my b is my y-intercept. So under step 1, I forgot what it was again. 5898. Again, you are using your own data. 5898 plus 218. So this is my slope for wet gas.
Minus 21.1.
Oh, I forgot my x, sorry. Yep,
0.5154 sound good?
yes,
Oh,
196 sounded for Y-intercept.
sure.
oh, I
Wait,
can
and then
calculate.
what's your beta? Oh,
Yep. So let's write down your equation.
515.
And are you guys at home ready to move on to step 2?
actually just the value that you would plug in.
All right, they're all laughing at us. Okay, so we have a problem, and that is we've got a wet gas, right? Because some of the water evaporated. So we're going to mathematically subtract out the water vapor. So the rest of the lab is, yep, the rest of the lab is how do we subtract out? See what I'm doing? I'm subtracting out the water vapor so that the only gas left is air. So we're going to do that mathematically. So the first step is we need to know what is the water vapor pressure at your T2. So everybody's sink temperature was different, okay, because you filled your own sinks. So to find the water vapor pressure, I'm just going to pick on RJ because he's right here. RJ, what was your sink temperature?
21.6.
Okay, RJ's sink temperature is 21.6. So Appendix O has the water vapor pressures. So his sink was 21.6. So that would round him up to 22. So looking at the chart, find your water vapor pressure,
Why for this do you not add the 273?
because this is pressure, not temperature. Oh, it's just because that's how they measured it. You can find water vapor pressure tables in Kelvin.
Okay.
It's just that this scale was in Celsius.
What one did you say it was in?
It's Appendix O, or you could just look up here. Can you see that, Lily? What was your sink temperature, Lily? So 22.8 would round up to 23. My sink temperature was 24.5, so it'd round up to 25. Back in the day, I would review interpolation with you. Interpolation is how do you find the value between 2 points? You use the slope. So like, what if your vapor pressure was, what if your temperature was 37? How would you find the value at 37?
Yeah, that's find it.
Yeah.
Follow the number and cross.
All right. How you guys at home doing? Did you find your water vapor pressure? Keith, you okay?
Yeah.
All right. So I'm going to write down my water vapor pressure. And step 3, I am telling you that P1 is the pressure of the atmosphere. So P1 is the pressure of the atmosphere. So maybe we should Let's check out the vapor pressure of the atmosphere, or the pressure of the atmosphere by asking our friend Siri. Where's the pressure? What is the barometric pressure of Verona, Wisconsin?
The barometric pressure is currently 30.01 inches of mercury.
It's British because my kids think it's funny to change it on me. The other thing they think is funny is to change my Zoom name to something inappropriate.
Wait, what is it? 30.01?
30.01. So I'm going to write that up here as well. It's inches of mercury is what she said. So 30.01 inches of mercury. What's what, Maria? We're going to calculate that right now. So our pressures in inches of mercury, we need it in kPa. So that's why back in the day, we practiced with easy, simple things, like how many hamburgers are in a bologna sandwich. You remember that worksheet? All right, so we're going to convert to kPa. I have inches up here, I put inches down there. Because I'm older than dirt, Karen, I know that there's 2.54 centimeters in an inch. Then we go from centimeters to millimeters. So my inches cancel. And now I have to figure out, okay, let's go to our conversion expert, Michael Comer. How many millimeters in a centimeter? Perfect. And now we're going to convert millimeters of mercury. There's 760 millimeters of mercury in 101.325 kPa. And that will get us our final answer in kPa. Oops. 101.325.
The millimeters cancel out too.
Yes, the millimeters cancel out. Should show that. Boop, boop.
So all of ours would be the same, right?
Yes, we're all operating at the same atmospheric pressure. Now, you can have just an aside. Operating rooms are pressurized slightly. So an operating room is slightly higher pressure. Why would you want your operating room to be a slightly higher pressure than the atmosphere?
But air doesn't get in.
That's right. So air doesn't get in. Air moves from high pressure to low pressure. That's what causes wind. So if the atmospheric pressure is 102, so that's my atmospheric pressure, 102. My operating room would be at 104. So then when I open the door to an operating room, the air is going to move out. It's going to push out. It's just a way to keep germs down, because otherwise what happens, you open up the operating room door, air would suck in, bringing dust and dirt and contamination. So operating rooms are slightly pressurized. Yep. Uh-oh, I've got one new message. Oh, you used the barometric pressure of 29.86. Okay, so like I said, you use the data from the video. Okay, don't use my data, use your data. So Ayan, you should use the 29.86 because that was the barometric pressure when I did the lab. All right, step 4. So this is P2 is equal to the pressure of the atmosphere. P2 is the pressure of the atmosphere minus the water vapor pressure from step 2. All right, so 102 minus 3.2. This would be a good time to review significant figures. When you're doing subtraction, you round to the guess furthest to the left. Do you remember when we did? Yep. So the guess furthest to the left is in the ones place. So I'm going to round to the ones. So my answer would be 98.8 would round to 99. Because I'm going to have to round to the ones place. All right. You okay? Any questions at home, Zoomies? Okay, like I said, we're going to mathematically get rid of that water vapor pressure. We're going to use what's called the combined gas law. So this is a good way to review algebra and also how do you attack a problem. So we're mathematically converting our wet gas into dry gas. Because nobody likes wet gas, Abraham. Dry gas is much better. Write down all of our info. Numbers in the right spot. P1 is 102. Right, P1 is right up here. I said P1 is your atmospheric. P2. There you go. V1 is, if you forget what your V1 is, go back to your data table. We're solving for V2 dry. T1, everybody's got a different T1, but they should be close. And our temperature must be in Kelvin. So I'm going to add 273. So again, the reason why we put this is so that you plug the numbers in the right spot. Because with 5 data points or 5 pieces of information, it's easy to put them in the wrong spot. Then we got to do a little bit of algebra. Ready for the algebra, Maria? Doesn't look like it. All right, so here's the quick way to do it. Multiply both sides by T2 over P2. That way they cancel. And then I'm left with T2 P1 V1 over P2 T1 V2 dry. Okay, so pay attention in your math classes. The further you go on in science, the more complicated the math gets in all fields. So even in biology, you'll start to get into complicated math. Now we can plug the numbers in. Oh, see, I plugged the numbers in the wrong spot. It's a good thing I wrote T2 is on top. T1 is on the bottom. Look, if I can make mistakes after all these years, so can you. There you go. So I'm just going to walk around, make sure everybody's got that calculated right. Yep. This is our class, right? This is That'll make a difference.
Yeah, we did it all the way to the top.
No, that's 250.
Yeah.
Yeah, like 239.68.
3 sig figs. So even with that slight difference, that's 50, and I got 240. 50 plus 240,
I don't know how that.
be 290. So even if I do this, even if I don't do that,
We had it look like it went way higher. It was like almost to the top of the thing.
well, you always got to be careful about those things.
Yeah.
This one is 242. 242 plus
Yeah, even that is still way less than that.
242 plus 50 is 292.
Yeah. Don't know where that went wrong.
All right. So we've got our V2 dry. Is there a spot to put in our data table? No, there isn't. Okay. So we're going to make a second graph. But for the second graph, instead of using, so you're still going to have T1 V1, but now you're going to have T2 V2 dry. So the only number that's going to change is that V2 dry. Instead of using 232.5, I'm going to be using 228. Okay. So go ahead and graph that, and then make sure you write down the equation of the line from your second graph, and then we're done for the day. Okay.
And this isn't.
How do you get the Y-intercept?
We're gonna do the whole lab together in class, so there's no homework tonight. The Fruit Loop lab, we're gonna do all together in class tomorrow as well. Well, you're gonna have time to work on it in class. I'm not gonna do it for you. The lab we're gonna do together, but the Fruit Loop lab, you're gonna do on your own in class.
So the first volume stays the same.
Yep, the for T1 and V1 stay the same. Do you guys have any questions at home?
You get the Y-intercept.
You gotta get your equation of the line.
I got the slope.
So if you got the slope, then you just plug in one of your data points to find the Y-intercept. Oh, wait, so here,
So what's your slope? 0.5154.
for what?
Just 5154.
5.154. Okay, so the equation of the line is this, right?
Yeah.
So I've got my slope.
Oh, yeah.
So the Y-intercept is where Y is
Intercept
0,
It
right?
tells you where B is.
So
But we
no,
couldn't
his
make a
thing
line.
is weird. So then you just plug in 0 there
Right.
and solve. Oh,
There's too many variables there,
you
though.
need X. So
I've got 2.
No, I think you don't have B in there. And then that's how you get the Y-intercept. Because
no, you need to have the Y-intercept in there. You need to know.
because we're solving for the Y-intercept.
You're solving for B. You're solving for B.
We
so
know
you need to
B.
know X.
Oh.
So
No,
what
this
you
is
would
for
do
us.
is
You
So-
don't, I know.
Our line was working.
what was your T1? What was your T1?
98.7.
Okay, and what was your B1?
You'd plug in 98.8.
250.
Yep.
We haven't come
So
back.
then you plug in
Yeah.
250 here,
We only go in.
and then 0.154 times your X.
Oh.
Okay, solve for B.
All right.
All right. That will give you your Y-intercept. Yes, right. So you could actually just take your old graph and just change the one variable. I'm going to write down my new, this is now for dry gas. So like I said, everything stays the same except for your V2 gas. I'm going to write down my equation. .6516. That's 212. All right. So once you have that graph, you guys can go ahead and log off at home. That would be acceptable, yep.
So if we have the screenshots, we don't really have to write anything here.
Yeah. I'm walking around and seeing that. You guys.
Oh, I got a line with stuff.
I don't know why it didn't do that.
This is for the second one.
Yeah, but it gave you the equation.
Like why?
Oh, but now my Y-intercept is 188 on here. Oh, I think I had a different thing.
Right. If you're going home for lunch, you guys can go.
What about the meditation?
Wait, okay. Me versus me and Zach.
See you later. How are you guys at home doing? Are you okay?
I know, it's the worst spot.
So I take screenshots of these two graphs. What if one doesn't have a line?
That's okay, because I know you're having trouble. How you doing, Karen? Sure.
Ready, Larry?
It should be a little bit smaller than that one. Yep, it is. Yep, that's right. Got your equations. That'd be good. We gotta finish doing the lab tomorrow.